Algebra 2, we're in 2.7 talking about a thing called compound inequalities. So there's two types. There's going to be some and problems and some or problems. Some information about these, but this is of not maximal importance for the next 2 minutes, but it's what I'm saying is true. The and problems are called conjunction problems. The only way I can imagine asking you about that would be if it were an extra credit question sometime to see if you remembered a little bit of trivia from this. There's a symbol you can use if we get into the set notation, which is that squiggly bracket thing that'll be back a touch today. This symbol gets used for these conjunction problems, for these and problems. And you might remember that because it doesn't have the little crossbar to make that an A, but that symbol looks a little bit like an A, just without the crossbar. These are also called intersection problems. If people have been through geometry, you remember that word a little bit better than the other people who haven't. Intersection is just where things overlap, things that are in common. So if we have this and that, there's an intersection there. There's some things in common. Or problems can be called disjunction problems. There's a different symbol there. It's the same symbol, but upside down. And those are called union problems, U for union. Union just means put this thing together. So, and problems can be written one of two ways. We could write x, whatever, x greater than 2 in this case, the word and then have an x less than or equal to 4. I don't usually write the and problems that way, because that means the same as this. My own personal name for these is to call these less than sandwiches. We've got the two ends and then the variable in the middle, like the meat of your sandwich. Instead of having greater than this and less than that, you can just jam the variable in the middle of a couple less thans. This is telling you it's more than 2, so is this. This is telling you it's less than 4, so is this. It's just less writing to write it this way. The book tends to do this as well. So instead of this and that, they'll just write the variable in the middle of a couple of those less thans to say x is between those things. If they want to do set notation, and I'll look at the homework and see if that's required of us, we would do 2 of these squiggly bracket sets. If it's an and question, we're going to throw that symbol in the middle. So x bar in each of them. Copy this in one of them. Copy that in another. We are going to, I think, do some graphing as well. When we graph, you want to put the numbers in number line order. 2 is smaller, 4 is bigger. So we'll do 2 on the left. We'll do 4 on the right. Since 2 doesn't have an equal, leave that open. That's exclusive. Since 4 does have an equal, fill that in. That's inclusive. And then if we want to be greater than the 1 and less than the other, we're going to be in the middle. That's the zone where we're bigger than 2 and still less than 4. Just essentially connect the dots on those. Voice failure. I'll be with you in a moment. If you're experiencing technical difficulties, please stand by. Or questions take a different approach. So if we want to do the squiggles, we'd still do 2 of them. We'd still do the x's. We'd still copy the one problem in the one group and the other problem in the other group. But the or questions are disjunctions. They're going to do the U on that if we want to do set notation. If we want to do graphs, we're still going to put the numbers in number line order. 2's in competition with 5, so 2 is smaller, 5 is bigger. The 2 had an equal, so I'll fill that in. 5 didn't, so I won't. If we want x under the 2, we'd go that way. If we want x more than 5, we'd have to go that way. So you end up with almost the whole number line. The or, it's easy to achieve success. Like if your parents would say to you, we're going on a trip, I want you to either clean your room or take out the garbage, or clean the bathroom, or clean the garage, or mow the grass. If you came home, parents come home, and you only did one of those things, they're going to be okay with you. because the word or, it's easy to achieve an or. Do this, or this, or this, or this, or this. You just pick one and you do it. That's easy. And is a tougher word. If your parents say, we're going on this trip, we expect you to do this, and this, and this, and this, and this. They expect all of that when they get home. That's a difficult circumstance. Okay? So when we do these graphs, the or graphs are usually almost the entire number line with like a little bit of failure possible if nothing worked out. The and graphs is usually just like a little bit of the number line. Like think about the whole number line and then what portion is it that's between 2 and 4. I mean, that's just a speck in the ocean of the world. But if we look at the number line and think, how much of the number line is either under the 2 or over the 5, it's almost the whole number line with just this little bit of failure in the middle. The ors are usually things that are filling up both directions, almost the whole number line with a hole in the middle. The ands are usually just a connected dot in the middle of the thing. Most of the homework's going to look more like this. They're going to give you a problem to solve. So if I gave you just this, we did that a couple days ago. Just do opposites. They're adding 5, so you'd subtract 5 to both of these. If I gave you this problem, you'd still subtract 5, but to both of those. What we're going to do when there's 3 parts to this is subtract 5 from everybody. Okay, so we want the variable alone, and that's going to be in the middle of my less than sandwich. To get rid of this, I'd have to subtract 5, but that's going to change all 3 positions. Subtract 5 from the 7 to get a 2. Subtract 5 from the beginning to get a -8. And if all they want is the solution, we're good. If the homework mentions something about the sets, we'd have to get our sets going with squiggle brackets and accidents. For the ands, we do the symbol that looks like an and. We copy x more than -3 in the one zone. Wait, from this answer, sorry. X more than -8 in one zone. X less than 2 in the other. I don't think they're going to care about that. Do you think they care about the graphing? We'll check. -8 would go on the left because it's littler. 2 would go on the right because it's bigger. And if x is between those, just play connected dots. For the or graphs, it's just like 2 problems in one. Just keep the word or alive. So act like this isn't here and just do the algebra on this. To get this x alone, you'd want to do the opposite, add 4. X alone, add 4. Then focus just on this. To get this x alone, you'd add the 7. So it looks like that. If they just ask us for the solution, we're good. If they want to do something about sets again, we can squiggle up. Ors go that way. X bar, copy this in one zone, copy that in the other zone, but I don't think they care about that, to be honest with you. I do think we're going to graph, so we go 1 versus 9, 1 is first, 9 is second. Now, maybe we build a bad habit here because by coincidence, the first number always has gone on the left in every story we've done. That doesn't always happen that way. So you want to do smaller number on the left, regardless of whether it happened to be first. So if these guys swap, you wouldn't put 9 and then 1 in that order. We're staying in number line order. We want x to be under the 1, so left of the 1. We want this to be more than the 9, so right of the 9. Almost always you'll go in opposite directions, but I did not say always. You're going to have to think each time about it. Go left of one, right of the other. It's usually opposite directions, but you'll have to think about it. Likewise, these are almost always connected dots, but I didn't say always. I said almost always. Homework we're doing here is 83. Let's take a look at what 83 tells us to do. 83 goes... Well, I skipped some examples on my paper, so I'll be back on the board in a second. But 83, it's a mix. 1 to 4 does say graph. 5 to 10 says solve. 11 to 16 says graph. 17 to 22 says solve. Nothing about solution sets, so squiggle brackets are absolutely out of play. And I need to keep going over here because I skipped some stuff. You have should have the notes paper by now. If you have a minute, just pause the video and do these 4 problems I just threw up, and then unpause me. I'll be back and explain them. For this, we're going to divide everything by 2's. So high end of 5, low end would become -2. For this, we'd have 2 things to do. We'd want to subtract the 4 first. So that sits in the middle. Subtract 4 on this end to -7. Subtract 4 on that end, 8. And then divide by -2. Dividing -2 makes -4. Negative dividing negative is positive, 7/2. And I'll bet I got some people with forgetting to turn the signs. That is still happening. Negatives multiplying or dividing is going to turn the graders unless it's back and forth. If you didn't turn that negative, see if you miss any in the future problems that we're about to hit. Negatives are going to turn sign. For this, I would divide by 3. Keep the or word in the answer. The word or can't disappear. Dividing by -2 turns sign again and gets us -5. This, I'd subtract 1 to get 6. Divide 3 to get 2. The word or still alive at every level. Here I'd add 3 to get up to -3. Divide 2 to get a fraction, -3/2. And now we're actually good. We're good to go.